All right, so we're going to talk about meters here, okay, and how to record our different values. We'll also talk about energy and power down here. Okay, so the three values we've talked about so far are voltage, current, and resistance. So we're going to talk about how to actually measure these, and then next, when we pick this back up, we're going to be talking about how to draw circuits. So we'll also talk about some symbols and diagrams. Okay? All right, so let's start out with the voltmeter. That's hidden right there, but it says voltmeter. Okay? The symbol for a voltmeter is a circle with a V, all right, and some wires. Okay? Those lines are like wires coming out of the voltmeter. Okay? All right, so let's say we're going to draw a circuit diagram. So our symbol for a battery looks like that. Okay? The big side is positive, the little side is negative. And then we got a wire coming out like that maybe. We might have a resistor. Okay? And so we've already talked about these two symbols on the other note page. Okay? Those are on the other side. This indicates a voltage source. This indicates a resistor of some type. Okay? Now sometimes we might throw a couple resistors in the circuit. So let's add one right there. Okay? And this circuit right here is exactly what I have laid out. Okay? Now instead of like drawing all of this stuff that I've got, it's way easier to diagram it. Okay? So that's what all of these symbols mean. Okay, so over here on the notes, for voltmeters, okay, they are connected in parallel. Okay, we haven't really talked about what parallel means yet, okay, but it means if I'm going to take this thing and I want to know the voltage drop across this resistor, I'm going to connect the voltmeter parallel to the resistor. Okay, now this meter right here, this is not a voltmeter. This is an amp meter. Okay, it is measuring current. We'll talk about that next. This is connected as a component within the circuit. Okay, this is actually connected in series, we would say. All right, so over here, I've got a voltmeter. Okay, now is it part of the circuit? No, it's not. It's not in the circuit. The circuit runs independent of whether I have this thing connected or not. Okay, so if I take this and I go over here and I connect it across this light bulb. It's kind of hard to see what I'm going to switch these here. Okay, this voltmeter, I've got it on the 15 volt scale. Okay, so I'm reading this middle scale right here. So how many volts is it reading right there?
25.
Okay, it's reading 2.5 volts. Okay. All right. Now check this out. I'm going to measure the voltage drop across this bulb. Okay. Basically, I'm kind of talking about how much voltage each bulb is getting from the battery.
So the
okay.
bulbs are the resistors?
The bulbs are the resistors. Okay. So how many volts is that resistor getting?
I would say the
Same amount. Okay, 2.5. All right, that only adds up to 5 volts. What's the voltage of my battery? 9. Okay, and we can test the battery's voltage by going like this. Okay. All right, now check that out. It's only reading about, not even 6, like 5.5 volts. Okay, and there's a couple reasons for that. The wires take up some of the voltage too. Okay, they are actually resistors. They're just a really low resistance, right? Okay. The battery itself has what's called internal resistance. Okay, so the bulbs, we would maybe think right away, oh, they're each going to get 4.5 volts, which adds up to 9. Okay, but that doesn't account for some of the loss within the circuit. And we'll talk more about that later. Okay, but the key is that the voltmeter is not really a part of the circuit. Okay? In your notes right here, I want you to put this down. Voltmeters operate at high internal resistance. High internal resistance. Okay, so that means if I connect the voltmeter right here, not a lot of current is going to go through it because this has a huge resistor in it, all right, and we don't want it to affect the circuit. If this had a little resistor in it, then the battery would just send the current through the voltmeter and our bulbs wouldn't get any current. Okay, does that make sense?
How would they not get?
Because current follows the path of least resistance. They would get a little bit of current, but the current will take the path of least resistance.
Oh, but because you had it connected up to each terminal.
I had it connected right there.
Okay.
Okay? All right, so the usefulness of the voltmeter is to see how much voltage this bulb is getting and how much voltage this bulb is getting. Okay, and we'll do more with that later too. Okay, current. A-M-M-E-T-E-R. Okay, you can think of it as an amp meter. Okay, but we don't actually put the P in there. Symbol for an amp meter is, yep, very logical. It's a circle with an A. All right, and here's how we would put our amp meter in this circuit. And this is what I've got going on right here in the example circuit. We'll put an A, and here's our light bulbs. Light bulb 1, light bulb 2, those are our squiggly lines, and our voltage source, which is our battery.
But you know, how can we put the bend there? Like, why the square? Why know that?
Okay, so these are connected in series. And we'll learn parallel and series. Those are a big deal. We'll learn those more later. Okay, but Connor's question, I don't have to make this a square. Okay, I could make it a circle. All right, usually we make it a square just because it's easy to draw. All right, Sawyer.
When you're drawing that, is it just like a coincidence that it's between the negative thing and the resistor, or does it have to be between negative and resistor?
Right here.
Yeah, the amp meter.
Oh, great question. I could put this amp meter any place in the circuit. Okay, I could put it right there. I could put it right there. I could put it right there. Okay. Now later, when we start doing parallel circuits, that's not really going to be true all the time. Okay. But the flow in this circuit, there's only one path for the current to take. Okay? So it doesn't matter the order of the devices. Remember, these resistors are going to decide how much current flows in addition to the voltage of the battery. Because you guys know this, current equals voltage over resistance. So if I put a 12 volt battery instead of a 9, what's that going to do to the current? Greater current. If I put higher resistors in here, okay, meaning probably like tougher light bulbs, okay, then I'm going to increase my resistance and decrease my current. Okay? All right, now the amp meter over here. Let's look at this. Okay, I've got it on the 500 milliamp scale, so it's reading off the top. So this means I'm getting 200 milliamps right now, or 0.2 amps. Okay, and notice it's connected. It is a part of the circuit, where the voltmeter, it's not really a part of the circuit. Yes, it is a little bit, but this is operating, so if this is high internal resistance, what's this operating at? Low. We don't want it to affect our bulbs, okay? So amp meters operate at low internal resistance.
Which makes it just okay good.
Mm-hmm. Okay, now an ohm meter. There's not a symbol for it that we use, or that I know of. Okay, and the reason why is because we don't use it in the circuit. Okay, if we're going to measure the resistance of something, didn't we do that in one of the other videos where we connected tons of things to the ohm meter? We measured people. Okay, these measurements okay, we're going to take these when there's no current flowing.
What happens if you do?
Well, I mean, I could connect it, and you know what? Actually, I don't really know.
Will it just like read inaccurate?
It might read inaccurately.
Try it.
I think I've tried it before. I don't have one sitting out right now, but it might. I think it might affect. I don't know. I'll have to check. It's a good question. Okay. No symbols except we're measuring resistors, so you'd have something like that, and you're connecting it at either side of the resistor. Okay? The point of this chart is for you guys to realize how these things are measured, because you're going to probably do 4 labs with this. Okay? So we need to know how to use all this equipment. All right. A couple other important things that are going to come up. Power. Okay, so let's talk about power and energy. All right, you guys already know that power is equal to work over time. Okay, and the units for this would be joules per second. Okay, now we learned that a long time ago. All right, it's how quickly work gets done. Okay, now in the electrical world, power is equal to current times voltage. Okay,